Okay, students, we're going to now start talking about explicit and recursive formulas, dealing with arithmetic and geometric sequences. Whether you knew what they were called, arithmetic and geometric sequences, I don't know. You've done these from probably elementary school on. What you haven't done yet would be writing the explicit and recursive formulas, perhaps. I don't know if you did in 8th grade math or not, but okay, so sequences, we have two types, arithmetic and geometric. Arithmetic means you add or subtract to get from one term to the next, called the common difference, D. So if we go down right now to example A here, how do I get from 7 to 15 to 23 to 31? I add 8. So that is an arithmetic sequence because I'm adding or subtracting, in this case adding. Okay. B, what am I doing to get from 1 to negative 2? I'm subtracting 3 each time. So that common difference is negative 3. Remember, it could be plus or minus. If I add or subtract to get from one term to the next, that is an arithmetic sequence. Geometric is when I multiply or divide to get from one term to the next, called the common ratio R. Now I say multiply or divide, but you have to write the common ratio as if you were multiplying. So remember, division is multiplication by the reciprocal. So if you're actually dividing by 3 each time, you have to change it to multiplication by 1/3. We're always going to write the ratio as a multiplication. How do I get from one term to the next? What do I multiply by? Okay, if you can't do either of those terms, either of those ways, multiplying, dividing, adding, or subtracting, then it's neither of these forms. Sequences. Okay. Also, other things to know. If they give you, here's a sequence here as well. They're adding 2 each time. These values that they're giving you here, these are the y values. Notice they're put down here. The first term, second term, third term, and fourth term, the number of the term itself are the x values. Notice right there, the x value, 1, 2, 3, and 4. It's the x value, so you could actually plot these points, 1, 2, 2, 4, 3, 6, and 4, 8. But the term itself are the x values. The numbers in the sequence themselves are the y values. You need to know that. Okay. And here's an example of just writing that out on the first one right here. First 4 terms, and there's the first 4 terms, adding 8 each time. The term number is the x value. The number in the sequence itself is the value of the term is the y value. Okay, so those were arithmetic, addition, an example of addition and subtraction. Geometric, here's an addition. Here, notice I'm dividing by 2, but remember I can't write it as divided by 2. Division by 2 equals multiplication by the reciprocal. So 2 over 1 becomes 1 over 2. Or as I wrote over here, 0.5. You can write either 0.5 or 1/2. Doesn't matter. And then here, we doubled each one. We times 2. Remember, we're always writing how we get from one to the other by multiplying, so that ratio is 2. So notice it gives you R. That's telling you already that it is a geometric sequence versus if you see a D involved, if they might give away something in the problem. If there's a D involved, that's a common difference. That means you should be adding or subtracting to get from one term to the next. Okay. Now, so that's just finding the common difference, the common ratio. Okay, that should be easy. Now, what we want to do, and what we're focusing on, so you've done that in elementary school and middle school. Plenty of those. That's what you've done. So the algebra part now is writing these formulas, either an explicit formula or a recursive formula for any of those above. Okay, so explicit formula, what it allows you to do, it allows you in one equation to get to any term you want. Arithmetic sequences are usually written in one of the following 3 forms, either slope-intercept form with y and x in there, or they could write the same thing in function notation. Remember, that's really just like y equals mx plus b. Or you can see it in this form. Okay, that's showing you have a sequence here, series going on here. Now, notice that all of these are written in these that I've got underlined in red are written in slope-intercept form is what that is. Okay, y equals mx plus b. Y equals mx plus b. Okay, so now what I need to remember, and I used this example A above here. That's why the A is right here. Okay, so that's the one I'm using right here. The common difference at D, that's my slope. Notice that's M. That's what I have down here. But remember, this first term was 7, right? But remember in y-intercept form, when I put that b there, y equals mx plus b, that's when x is 0, right? Anything on the y-axis, x is 0. So that's why I said right here, 7 is the first term, so you must go back one term to get the x equals 0 term if you write in slope-intercept form. So what was the difference? 8 each time. So I started at 7 is the first term, and I go back 8 more to get to the 0 term. 7 minus 8 is -1, which is what you have right here. So the b is -1 right there. Slope is that common difference, 8. So y equals 8x minus 1. You don't have to write the plus and negative. I just have this programmed in, so it has to write it out like that. But 8x minus 1 is what you'd write. Okay, or in function notation, f of x equals 8x minus 1. Or in arithmetic, this series or sequences notation, a sub n, sub means below, equals 8n minus 1. You wouldn't write the plus minus, just 8n minus 1. Okay? So that's how, when you watch the video that I'll show you and explain the different problems that I've worked out from the DCAS from several years past, they'll often have it in slope-intercept form. But if you look on the internet and look at the formula for writing it out, it's going to write it like this right here. I got this right off the internet here. A sub 1 always refers to the first term. N is the current term. I have that written down below down here. Okay. A sub 1 is the current term. A sub n minus 1, when you get down to here, that's the previous term. Okay. That should have been an A sub 5. I got cut off there. And n is the, so n represents the current term. Okay. D is your common difference. We already had that above. You calculated that above. Common difference. Remember that, and that can, even though difference you using subtraction, that can be adding or subtracting. Okay. In the A sub 1 refers to the first term, not the 0 term, the first term. Remember, to get the 0 term, we'd have to go backwards like we did here to get that -1, that 0 term. Okay. So that's what they give you on the internet that you'd fill in. So is there any difference between this and what I've got written right here? The answer is no. So it looks different. It's written in a different format, but it's the same thing. So let's see that. Okay, so A sub n would be like my y. This would be like the y right there. Okay. A sub 1, remember A sub 1 was that first term. That's that 7 right here. There's the first term, 7. So there's the first term, plus that common difference was 8. And then we're looking for, let's say we want the first term. Oh, well, you don't have to write n minus 1. Okay, right there. Just write it like that. Okay, so is that any different than this right here? And the answer is no. Let's look at it. I'll put it down here. Remember, I need to distribute the 8 through. So I have 7 plus 8 times n is 8n, and 8 times -1 is -8. Okay, so now I need to combine like terms. And what do I get? Y equals 8n, and what is 7 minus 8? -1. The exact same thing that we have right up here. Okay, so these are the same thing, just written in different forms. This right here would give me the exact same thing as I had right there. So you can either choose to memorize this right here and just plug those in, and then you'd plug in the A sub 1 like we just did right there. Okay, and then you could distribute like I just did and write it into slope-intercept form, because that's how a lot of them were written on the DCAS in slope-intercept form. So I can either do that, or I can say, okay, I know I'm writing in slope-intercept form, that common difference is my slope, and this is my first term, so I have to go back one more term to get to the 0 term for that y-intercept. What was that common difference? 8. So I need to subtract 8. 7 minus 8 is -1. And I have it right there. And I can write 8x minus 1 right away. So to me, that's the easiest way. But if you want to go ahead and remember this formula here and then do it that way, you can. All right, next is how do I write another way of writing that same thing, but it's called recursive formula. Now, here's the difference. Recursive formula has 2 lines of information always. Now, if they go ahead and put it into one line, they're going to have to separate it by a semicolon. So they could, it's usually written in 2 lines like this right here, line 1 and line 2. But if they wanted to, let's just say that A right there, I could have written this as A sub 1 equals 7, semicolon, A sub n equals A sub n minus 1, and then plus 8 for writing that information down. That's really 2 lines, that line and that line. They just have it separated by a semicolon. Okay, it's so on the DCAS they've written it both ways, so you got to be familiar. They might put both pieces of information on one line right there separated by a semicolon, or they have it written out in 2 lines like this. Okay, as you see there. Okay, so it's not one piece of information, not one equation like we just did in the explicit way. So notice what it says. The first piece is always written is always the first term itself. Always. It's always going to be A sub 1 every single time, no matter what. A sub 1, whatever the first term is, that's what you have to write down for recursive formula. The second piece is an equation. Notice it's got the equal sign of how I get to the following term based on that first term, often called the previous term. Okay, so I'll write down that sequence again. 7, remember we added 8 each time. 15, 23, 31. That's what A's sequence was above. Okay, and that's why I'm just doing the same one again, just writing it as the recursive formula now. So again, the very first thing I always have to do is write down A sub 1 equals. Well, here's my A sub 1. There's the first term. I write down A sub 1 equals 7. That's always the first thing. The second thing, you're going to write down A sub n. Sub, remember, you don't say AN, you say A sub n. Sub means below. The n is below the A. So how you pronounce this is the A sub n equals A sub n minus 1, and then plus 8. Okay. Another way in words, how you can say this is the current term. Notice I have it right here. The current term equals the previous term. Notice A sub n minus 1 is called the previous term. So the current term equals the previous term plus the common difference. 8 was my common difference. That's what you have right here. So this is the general setup. A sub 1 equals whatever A sub 1 is. The current term, A sub n equals the previous term. That's the A sub n minus 1. It's always the previous term plus the common difference. Remember, D stands for common difference. For n greater than or equal to 2, because you already got the first term right there. So now you're going to n being the second term and higher up. So what does this mean? This means I can't jump to whatever term I want. I can't jump out. If I want the 5th term right now, I can't just go from A1 to A5. I have to do A1, A2, A3, A4, and then get to A5. So this is a longer route of getting to, a term that you're wanting, unless you're wanting the 2nd term, for example, then it's no problem. But you have to go by each previous term every time you have to fill it in here. So you're going to have to all write both of these types of equations. I think they're all multiple choice. I've seen when I worked them out on the DCAS, unless it's asking you for a specific thing like the common difference. Okay, so what do we have here now? Let's go back to our first one here. A sub 1, the first term, 7, right there. So I want the second term, or the current term, A sub n equals, my equation is the previous term plus that common difference. That's what it's going to be written at every time. So I just copy that down. And what was my common difference? 8. 7 plus 8 plus 8 plus 8. Common difference is 8. That always goes second. So this is how you're going to write your equation for that right there. Okay, and we're going to practice that with B, C, and D below here at the bottom. So these are in my notes, and then in class I'll hand these out, and then you're going to do B, C, and D above. All right. So fairly easy for arithmetic sequences. Again, that was for arithmetic sequences, both of those, the explicit and the recursive for arithmetic sequences. Not too bad. Okay, now geometric sequences. Remember, those are the ones that you either multiply or divide to get from one term to the next. These are its equation that you're going to set up. For the explicit, oh, I forgot the X there. For the explicit formula. Okay, so remember A sub n is always the current term. A sub 1 is always our first term. R is that common ratio. Remember, since it's R, that means you multiply by a number to get from one term to the next. Remember, we didn't use D. We're not using D now. D is up here for arithmetic sequences. You're adding or subtracting. R is telling you that I'm multiplying by some number or a fraction to get from one term to the next. And then it's raised to the power of n minus 1 right there. Okay. And I can, since remember it's only one equation, again, since it's only one equation, that tells me it's an explicit formula. Remember, I don't have two lines like down here. Here's my 2 lines. That's for recursive formula. Explicit formula, 1 line, 1 equation. Recursive formula, 2 lines, 2 equations. And the first equation is always A sub 1 equals your first term, whatever your first term is. Okay, so let's look up here at C. Oh, we'll do D. Okay. So our common ratio is 2. 5 times 2 is 10 times 2 is 20 times 2 is 40. Okay. Our A sub 1 equals 5, right? First term is 5. So notice all I'm doing is filling that in right here. It tells me what to fill in. A sub n, I write down A sub n. That's the current term equals A sub 1, which was the 5, right? Times the R, and you want to put that in parentheses, 2, and then raised to the power of n minus 1 every time. A sub 1 every time right there. Never changes. Whatever your sequence is, that A sub 1, the first term goes right there. This is my R, the common ratio, and it's always raised to the n minus 1. That never changes. Okay, A sub n doesn't change. Okay, so now that would be the equation for that problem we just did right there. So how can we check that we have it right? Let's just say I go to, well, 5, 10, 20, 40. I'll just write down here so I don't have to keep going back and forth. 5, 10, 20, 40. Okay, well, I know 40 is the what term? 1, 2, 3, fourth term, right? So let's fill it in. A sub 4, meaning the fourth term, equals 5 times 2 to the, I want the fourth term, so 4 minus 1, n is that same term I'm looking for. Okay, I'm just filling in, and I filled in 4 there. I'm going to fill in 4 there because I want the fourth term. Okay, so 4 minus 1, a to the sub 4 equals 5 times 2 to the 4 minus 1 is 3. What is 2 cubed? 2 cubed is 8. What is 8 times 5? 40. And there you go right there. We verified that we wrote down the correct equation. That's called the explicit formula because, again, I said it's one equation. You don't write down the first term up top. Now we're going to do the same thing. We're going to write a recursive formula. Okay? And so here's the rule for all recursive formulas dealing with geometric sequences. So you notice it says for geometric sequences. So we have R, we only have R in geometric sequences when we multiply a previous term. So here it tells me what to write down, a sub 1. Well, I know the first term is 5. So I write it down. We're doing that same one. Then I write down a sub n equals a sub n minus 1 times, now I like putting the common ratio out front first. So the common ratio is what? 5. I mean 2, I meant. Times a sub n minus 1. Okay, that would be my recursive formula right there. That would be my answer. Okay, all I'm having to fill in is the a sub 1, which is the 5. That's easy to pick out, the first term. This a sub n stays the same. This a sub n minus 1 stays the same. You know, the only thing I'm having to fill in is the common ratio, 2. Like I said, I like putting in the other order, putting the 2 fourths. Remember, 2 times 3 is the same thing as 3 times 2. So remember, that's called commutative property of multiplication. You can switch the order. Okay, so now in this case, I can't jump. Remember, I can't jump from a sub 1 to a sub 4. Remember, we're going to go back. We're going to find the fourth term. We know it's supposed to be 40. I can't just jump to a sub 4 here because a sub 4 would equal 2 times a sub 3 because 4 minus 1 is 3. But I don't have a sub 3, do I? That's why I can't jump right to it. So I have to keep working, starting at a sub 1 and work my way up. It says 5. So a sub 2 equals 2 times, remember, a sub n minus 1 means the previous term. The previous term from 2 is 1. Well, there's that right there, 5. So a sub 2 is 10 now. That's my answer. So now I want a sub 3. I have to do 2 times a sub 2. And so that's 2 times 10, which is then 20. And now if I want a sub 4, I need to do 2 times the previous term of 20, which is the a sub 3. That's a sub 3 right there, previous term. And 2 times 20 is 40. So I still can get up to the 40. It just takes more steps doing it with the recursive formula. Okay, so here's your notes. This is what you're going to be doing on your assignment. Okay, you're going to first find the common difference or common ratio, depending if it's an arithmetic or geometric sequence. Then you're going to write an explicit formula and a recursive formula. Okay, and there's examples of that. Here you have it right here. We're going to do the other examples in class. Make sure you have it. You can add it to the back of the sheet or the bottom of the sheet so you have more examples. We're going to do B, C, and D. If you watch this video ahead of class and you want to try to write out those explicit and recursive formulas for B, C, and D. Well, actually, we did D. So B and C we still have to do. Okay, so I just did D here. B and C, if you want to try to work those out before you get to class, and then you can see if you're doing it right. I might offer extra credit for the first 2 that get B and C right. And so if you've watched this video ahead of time and you go ahead and do B and C, and I say, raise your hand when you have it done, and you've already done it ahead of time, you can immediately raise your hand. I come by and check your answers, and if you got them right, you're going to be the first few to get extra credit. All right, that ends it.